For our next example, we're going to prepare a set of differential leveling notes for an open level section. Recall that an open level section begins and terminates on different benchmarks. In this example, we're beginning our differential leveling by referencing benchmark 1 with a known elevation of 700.00 feet above sea level. Note that we close on benchmark 2 with a known elevation of 698.52 feet. Another important difference between this example and the previous example is that we do now have side shots. Note that from our second instrument setup, we take a foresight reading onto manhole 1. This will be categorized as a side shot. And then from our last instrument setup, before we close on benchmark 2, we take a side shot reading on manhole 2. We begin our open level section by referencing benchmark 1 with a known elevation of 700.00 feet. From our first instrument setup, we take a backsight reading of 10.01 feet on this benchmark, giving us a beginning height of instrument of 710.01 feet. From our first instrument setup, we look ahead and take a foresight reading onto TP1. Our foresight reading onto TP1 is 8.23 feet, which, when subtracted from our HI value of 710.01, gives us a ground elevation on TP1 of 701.78 feet. Picking up our instrument and moving it to the new location, we make a backsight reading on TP1, and this backsight reading is found to be 7.46 feet. Adding the backsight reading of 7.46 feet to the known ground elevation at TP1 gives us a new height of instrument of 709.24 feet. Note that from our new instrument setup, we now have two shots. We make a foresight reading onto manhole 1 and a foresight reading onto TP2. Be careful here. You want to make sure that the foresight readings on each of these points are subtracted from the same HI value, in this case 709.24. Additionally, in terms of note-taking convention, it's preferable to list your side shots in your notes prior to the turning point. So with that convention, we're going to list our manhole 1 shot first, and our manhole 1 foresight reading was given to us as 5.00 feet. Subtracting 5.00 feet from our current height of instrument, 709.24, gives us a ground elevation at manhole 1 of 704.24 feet. Now, from the same instrument setup, we make a foresight reading onto turning point 2. Again, be careful here. The foresight reading onto TP2 is given as 8.56 feet. That value should be subtracted from the height of instrument, which is 709.24 feet, giving us a ground elevation at TP2 of 700.68 feet. Now we pick up our instrument, move it to the new location, and make a backsight reading onto TP2. The backsight reading onto TP2 is 2.34 feet, which when added to the known ground elevation at TP2 gives us our new height of instrument, and the new HI value is 703.02 feet. At this new instrument location, we look ahead and make a foresight reading onto our third turning point, and that foresight reading is given to us as 0.65 feet. Foresight readings are subtracted from HI values, giving us a ground elevation at turning point 3 of 702.37 feet. We pick up our instrument, move it to the new location, which happens to be our final location, make a backsight reading onto TP3. That backsight reading is given to us as 4.35 feet. And adding that to the ground elevation at TP3 gives us our new and final height of instrument value, which ends up being 706.72 feet. Here, once again, we find ourselves making two foresight readings, the first onto manhole 2 before eventually closing onto benchmark 2. So again, in terms of note-taking convention, we want to record our side shots first, in this case, manhole 2. And we have a foresight reading on manhole 2 of 1.20 feet, which, when subtracted from our height of instrument value, gives us a ground elevation of manhole 2 of 705.52 feet. We have one final shot to make from our last instrument setup, that being onto our closing benchmark, benchmark 2. Here we make a foresight reading of 8.23 feet. And that foresight reading should be subtracted from the current HI value of 706.72 feet, giving us a ground elevation at benchmark 2 of 698.49 feet. We can pause here and compare our field-determined elevation of benchmark 2, 698.49 feet, with that benchmark's known elevation of 698.52 feet. So once again, we do have misclosure present. Knowing that we do have misclosure present, our next steps are to first quantify that misclosure, second, evaluate whether or not that misclosure is within an acceptable range, and if so, number 3, perform adjustments to our field elevations using the procedure from the previous problem. In this case, we have a known elevation at benchmark 2 of 698.52 feet. However, our field elevation is determined to be 698.49 feet. Looking at the difference between those two values, we have a total magnitude of misclosure of 0.03 feet. It's important to note in this example, our field elevation for benchmark 2 is actually low, meaning that we're going to be applying a positive or upward correction to our elevations. This is different from the previous example problem where we came in a little bit high on our closing benchmark. Here we have a total of 4 instrument setups. Looking at the equation for our allowable misclosure, we determined that an acceptable misclosure for this scenario is 0.04 feet, meaning that we are in fact okay with our actual misclosure of 0.03 feet. Performing the adjustment process, similar to the previous problem, we look at our total misclosure, 0.03 feet, divided by the number of instrument setups, in this case 4, yielding for us an incremental adjustment value of 0.0075 feet. At instrument setup 1, we will apply this actual value, 0.0075 feet. At instrument setup 2, we'll apply 2 times that value, or 0.0150 feet. At instrument setup 3, we will correct elevations by a value of 0.0225 feet. And then finally, at our 4th and final instrument setup, we will apply a correction value equal to our misclosure of 0.03 feet. Another important distinction between this problem and the previous problem is that we do in fact have side shots present. At instrument setup number 2, we take 2 shots, a foresight reading onto manhole 1 and a foresight reading onto TP2. At instrument setup number 4, similarly, we take a foresight reading onto manhole 2 and to benchmark 2. At each of these locations, we will apply the same magnitude of correction to all shots taken. At instrument setup 1, our total correction is 0.0075 feet. Again, in this example, our field determined elevation at the closing benchmark is low, and therefore all of our adjustments are going to be upward or positive. Making an adjustment of 0.0075 feet to the one lone shot made from the first instrument setup, we have a new field elevation for TP1, an adjusted elevation for TP1 of 701.79 feet. Moving ahead to our second instrument setup, our magnitude of correction is going to be 0.015 feet. And again, we're going to apply that same correction to both foresight shots that were made from this instrument setup. So our new adjusted elevation for manhole 1 when applying the 0.015 feet for correction is 704.26 feet. Applying that same magnitude of correction, 0.015 feet to TP2, gives us an adjusted TP2 elevation of 700.70 feet. Moving ahead to our third instrument setup, our magnitude of correction for the lone shot made here is 0.0225 feet, which when applied to the field elevation at TP3 gives us a revised elevation of 702.39. And then finally, moving ahead to our fourth and final instrument setup, we have a total magnitude of correction here equivalent to our actual misclosure, 0.03 feet. And once again, because we do have multiple shots being made from a single instrument setup, we're going to apply the same correction to both of those shots. Applying the correction of 0.03 feet to manhole 2 gives us a new field elevation of 705.55. And applying the 0.03 feet correction to the shot made on benchmark 2 gives us a corrected elevation of 698.52 feet. And that is in fact what we know the elevation of benchmark 2 to be.